factor polynomial or factorial polynomial represented using the notation x raised to n, and the power n is written inside brackets. X raised to n denotes products of n consecutive factors starting from x, and the following factors will be subsequent factors at the interval of distancing h, that is x raised to n equals x into x minus h into x minus 2h into x minus 3h into etc. x minus n minus 1h. Here we are evaluating product of consecutive factors, and in total there are n factors. When h equals 1, we have x raised to n equals x into x minus 1 into x minus 2 into etc. x minus n minus 1. This notation x raised to power n, where n is appearing inside brackets, denotes the factor polynomial or factorial polynomial. Let us evaluate forward differences of factorial polynomial. First forward difference of factor polynomial x raised to n equals x plus h the whole raised to n minus x raised to n. X plus h the whole raised to n becomes x plus h into x minus h into etc. x minus n minus 2 into h. Here we are taking product of n consecutive factors. X raised to n means x into x minus h into x minus 2h into etc. x minus n minus 1h. Here we are having again n factors. From these two expressions we can take x into x minus h into etc. x minus n minus 2 times h common outside, and we have x plus h minus x minus n minus 1h left out. Since this represents product of n minus 1 consecutive factors, we can write it as x raised to n minus 1, which is a factor polynomial. And here we are left out with n times h. After we cancel x and negative x, also h and negative h. Thus we have first difference of factor polynomial x raised to n equals x raised to n minus 1 into n into h, where x raised to n minus 1 is the factor polynomial. Similarly, we have the second difference obtained as delta square of x raised to n equals n into n minus 1 into h square into x raised to n minus 2, where x raised to n minus 2 is a factor polynomial. Moving on, like this, we have the general expression delta raised to n applied on x raised to n equals n factorial into h raised to n, which is a constant. And because of this reason, delta raised to n minus 1 applied on x raised to n will be 0.